All right. So uh, before I talk about the midterm, I guess everybody can sign into the iClicker because for today's lecture, we're still going to use the iClicker to answer to do several polling. Although we don't have that many questions, but still, it's good to know what's your thinking for those questions. Okay. So here I show you the results for the midterm one for the complete class. And you can see that the distribution is it's strongly left skewed. And actually, right after the midterm, I did a very convenient sampling for the student, and I asking them how they feel about midterms. And according to the feedback, it seems they feel it very easy. But of course, this sampling could be biased because it's a convenient sampling. And but in fact, according to the results, it seems it is the midterm one is not that easy as you thought, because although most questions are directly coming from the practice question, but we do have several challenging questions that you need to think more beyond the question, especially you have to considering or combining multiple knowledge points together. Like I remember there's a question about what's the median for three different indigenous group of Canada. So in fact, for that question, I put a word about know that the indigenous group is they are treated equally. So I put in that words is trying to give you a hint that those different categories cannot be sorted out. So in that case, we have the nominal data rather than ordinal or even continuous data. So for the nominal data, we cannot really tell the median. So I guess just be very careful about the words of the question because I didn't put those words in vain, right? So just be very careful. So the median for this midterm is around 15, which is 75%. And I guess the most student is clustered like in the Q1 and Q3 over here, which is between 13 and 17. And what is good to know that I did a further study. I want to see that because for this midterm, we have two different approaches for the proctoring because we have the Zoom proctoring and the proctor track. So I compare what's the score between these two different groups. And actually, I'm very satisfied with the results apparently because I think the difference is very small. And you can see the median is exactly the same and the mean is just like the difference is less than 0.2. So I'm very happy for this results. That means the method you choose for the proctoring not really influence what the grade you will get probably. So this is exactly what I'm going to talk about. So for today, I'm going to talk about how do we design our study. And here I would like to uh, give you a warning that today's lecture, it will be really difficult comparing to the previous lectures. In a sense that in today's lecture, you are going to see a lot of new ideas and concepts. And I guess what you could do is to just to focus on the big picture of those ideas and to see what those terminology means. And you just emphasize what's their similarities and what's their difference. So in the last lecture, we talked about sampling because before we conducting any numerical analysis or graphical summary, we need to collect the data and that's where our sampling come into play. But what is that sampling for? And for when we do sampling, we need to have some goal, right? So that is the today's lecture about. And today's lecture, we are going to set the goal for our whole study, where we are going to we are going to give a specific reason that we're collecting the data or doing the sampling, and also to do the summarize of our results. And here I would like to emphasize that the study design itself is actually independent with the sampling procedure. So when we when we design our study, we probably already collect our data, or we don't have any data at hand. So both are possible. So in this course, we first just assume that our data is sampled or could be sampled very easily. So I'm going to just come back to the cats example again. So in the previous lecture, you have seen that my friend, who is apparently very scientific person, and she collects a lot of information about the cat. And one of the characteristics that she's collecting is the cat's moods. And we know that for this moods, it's discrete data because we can only take either happy or sad. And actually, my friend is trying to go further or go beyond than just collecting the data of the moods. So she was trying to understand, well, since there's different kinds of the moods for the cats, so what's the specific reason that cause the cats to behave differently on each day? So what she did is she recruited another set of the data, which is the data of the weather on each day. So here for the weather data, it's also binary in a sense that we only consider two different types of the weather, either the sunny or raining. So right now you can see that for each day we have two information. The first piece of the information is for the Cheetah's moods, and the second one is describing what's the weather on the same day. So here is a perfect example, like what we are trying to do in a study design. So here, what we are trying to do is to analyze what's the relationship between the moods and the weather. And before I introduce what's the study design talk about, like before, I'm going to quickly go over several important terminologies that we need to use for today. So the first terminology is the variable. I guess you probably heard a lot of time from me that I talk about variable that or I mean, I was talking about it unconsciously because we often use this terminology rather than just use the data. Because for variable, it's a more statistical terms in a sense that we focus on the difference value for the different individual objects. So sometimes the variable, you can just replace the data by the word variable in many cases. And according to the nature of our data, we have two different types of the variable. So we have the continuous variable and the discrete variable. Apparently, this is coming from which type of the data we have. So if we have a continuous data, then we are talking about continuous variable. And if we have a discrete data, then we talk about discrete variable. So like for the mood and the weather, both of these data or both of these two variables, they are both discrete because they can only take countable many of the categories or values. So our mood can only be sad or happy, and weather can only be sunny or raining. So it's discrete. And an example for the continuous variable would be like the walking distance. So for walking distance, there's infinitely many measures, right? Because you could be 1.5, 1.55, or so there's infinitely many possible way to measure your walking distance. So I guess you can just tell what type of this variable according to what type of the data they are in. And for today, there's another even more important categorization for those two different variables. So right now, we just talk about the type of the data. But now we are going to shift into what's the goal or what's the role those variables play in our study. So right now in our study, we are trying to analyze is what's the impact of the weather to the different moods of the cat. So we called the variable that is measure the outcome of the interest, which is the mood here, to be the response variable. So it's similar like when we do our experiments and then we just we change something and when we see what's the response of our object. So that's why we call it the response variable. And in statistic, we usually just ignore the word variable and we will just call it response. So probably in the following slides, I will just use the response because it's much simpler than calling it response variable. And if we come into another side, which is we're looking at the factors that influenced our response. And for that one, we call it the explanatory variable because we're trying to use the weather to trying to explain why we see a variation in the different moods of the cat. So that's why we call it the explanatory variable. And in fact, in different fields or different contexts, you'll probably see the different set of the concepts, but they are actually exactly have the exactly same meaning. So in statistics, we usually talk about the explanatory variable to the response variable because we are trying to look at what's the variation of the value itself. And we are trying to use the value to explain what's the influence of the first variable to our second variable. And in the economy context, we sometimes will call the explanatory variable as the independent variable and the response as our dependent variable. So this is coming from an idea in the economy that we just treat when we study the association or the relationship of the two concepts, we usually treat the first concepts to be the independently changing. And that is it's not the thing that we are trying to study it. But we are trying to study is what's the variable that's depend on those independent variable. For example, we are trying to see what's the average income impact on the say the unemployment rate, right? So in that case, because the income itself, we treat it as independently changing. And here we are trying to study how those unemployment rate is rely on the changing of the income. And for the health science, like for example, in the clinical trial and in some other similar setting, we use exposure and outcome. For example, the exposure could be like your exposure to COVID-19 virus, or it could be some other like your habits, for example, your smoking status. It could also be the exposure. So in the health science context, I guess this set of terminology is more frequently used. So, but here, what you need to know is that these three sets of the concepts has the exactly same meaning. Okay. Any questions so far? Okay. So after talking about the several terminology that we are going to use in the complete lecture today, we're going to go over the most important part for today's lecture. So today's lecture will be divided into two parts. And in the first part, we will talk about the first big category of the study, which is the observational study. And the second part, after the break, we're going to head into the experimental studies. So the difference of these two type of the study is based on our explanatory variable. So for the observational study, it's saying that basically our variable of the interest are naturally vary among the individuals. So what that means is that both our response, for example, the cat's mood, and the explanatory variable, and which is the weather, they can be observed. So in that case, we didn't to use our judgment or our decision on the data itself. So for that type of the study, we call it observational study. And for the second big class of the study is called experimental study. So for the response, it is actually the same as the observational study. But what is the difference is how we get our data from the explanatory variable. So for the explanatory variable, we usually are going to manipulate our results. So for example, in the first slides, I mentioned I trying to study what's the influence of the different proctoring approach to the score of the students, right? So in that case, our response will be your score and our explanatory variable will be different approach. So in that case, because what I have is I already got the complete data. So I didn't do any changing, like to do any changing of your explanatory variable. So in that case, that study should categorize into the observational study. However, say if I'm a very bad person and I'm trying to assign some of you, and I mandatorily ask you to do Zoom proctoring, and I mandatorily ask another set of the students to do, say, proctor check. And in that case, that type of study will be the experimental studies. So an example for the observational study will be like the survey study. So you collect all of the information from the survey. So all of the data is already observed at the time point when you design the study. But for the experimental study, like the clinical trial, we did not really decide what's our explanatory variable should be yet. Like in the previous example, the Zoom and the Proctor track, I haven't decided which approach you should take. And in that case, that will be the experimental studies. Okay, so I guess right now you have seen these two important categories of these two. And so what's an example for the observational study? So the example for the observational study is exactly what I talked about at the beginning, where we are trying to study what's the relationship of your proctor approach and your scores, right? So because at that time, when I conducting the study, I already have all of the information you have. I already know what is your score, and I already know what approach you are taking, right? So in that case, both of the response and the explanatory variable, they both known to us. Can one be an example of both? No, so for each study, it can either the observational study or the experimental study, but not both. It cannot be, because your explanatory variable cannot be both observed or both manipulated, right? So it can only be one type of it. So before I introduce which specific subtypes of the different class of the study, so let's do a quick survey, like what is the study design for the cat study, where we are trying to study the relationship between the weather and the cat. So remember, for this, what we are looking at is the only difference is looking at the explanatory variable, right? So what is the explanatory variable in our case? The explanatory variable is the weather, right? So the weather, can we purposely change the weather? Unless we are God, right? But so in that case, in our study, we can only just record what is our weather on each day. So in that case, we can only treat the explained variable to be observed rather than manipulated, because we are not purposely assigning the weather on each day. So that's the difference. Oh, so there's a question about observational outcomes are not predetermined and the experimental is not. So pay attention. For the classification here, the observational and experimental, we are not talking about the outcome. The outcome is a response, right? So the response are the same. Because for the outcome, we always are going to observe it, because we are not going to change the outcome we have, right? So what is the difference is the impact factor or the explanatory variable. So for the observational study, it's like we just record it is what it is. So today it's sunny. Okay, I record it's sunny. And today it's raining. I record it's raining. And for the experimental study, it's like, okay, I'm the god. I'll change the weather today. So today should be sunny. Okay, then I'll see what's the impact of the sunny to the cat. And today should be, say, raining, and I'll see what's the uh, impact for it to it. So the answer here is the A. It should be an observational study because our weather, our weather here should be observed. It cannot be manipulated. And in the following lecture, you are going to see more examples in these two different studies. Okay. Right. So I cannot change the weather and on that day. So that's why we call it observational studies rather than experimental study. Okay, so in the first half of the lecture, we're going to focus on the first big class of the study, which is the observational study. And we know that for this type of study, both our response and our explanatory variable, they are observed to us. So in fact, the study of the weather to Cheeto's moods, the relationship of these two different variables can be categorized into the most basic study of the observational study, which is the survey study. And sometimes the survey study is also known as the cross-sectional study. So the characteristic of the survey study is like at the time point when we're trying to conduct the study, we already know all of our data for both the response and our explanatory variable. So like when my friend's trying to study the association between the weather and mood, she already get the complete data here, right? So that's why we categorize this into the survey study. So in the survey study, what we usually do is that we, so far, because both of our response and explanatory variable, they are discrete variable. So we just see what's the combination of them. So right now we have four different combinations. So say we have the happy mood together with sunny day, and we have sad mood together with sunny day. And we also have sad mood with raining day, and also happy mood in the raining day. So we have four different combinations on each of the variable, right? So in this case, we can describe all of this data into this 2x2 table. And we just count what's the number of each combination in our data set. So say we have 10, this combination of happy mood with sunny, then this value should be 10. And there are only like two counts or 2 days which has a sad mood for the cat in a sunny day. And that's why we put 2 here. So in this way, we can we can summarize all of this data into this 2x2 matrix or 2x2 table. And we are going to tell the association just according to this 2x2 table. So then how do we tell whether it is associated or not? So in fact, for the survey study, you can look at from the both way. So for example, you can start with the horizontally. So for the sunny day, the majority times the cat will be very happy. But for the raining day, the majority time the cat will be very sad. So that implies there could be association of the cat in a sense that the cat will be more happy when it's a sunny day. And you can also interpret this table from the second direction. So say when our cat is happy, the majority day will be sunny. And when our cat is sad, the majority day will be raining. So in this case, this 2x2 table basically implies a very strong association between the variable of the weather and the variable of the moods of the cat. And in our words, what the conclusion we can draw is that our response here, which is the cat's mood, is strongly associated with the explanatory variable, which is the weather here. So in fact, For a 2 by 2 table, we usually can tell this how strong the association according to according to which cell the largest value is located in. So for example, in this 2 by 2 table, the largest value is located in this diagonal term, and then it implies a strong association. So usually when we see some pattern like this, like the large value located on the diagonal way, then that is a strong association. If it is not located in the diagonal, then that means there's not that much association behind it. Okay, so let's do a quick survey. So for if we change our data and we result in this 2 by 2 table, what's the association between the moods and weather? Does that still a strong association? Remember just now I say when we look at association in a 2 by 2 table, we look at whether the large value is located in a diagonal way. So it could be so yeah, for this table, you can compare that. Yeah, I guess the majority of students get it right. So the answer is yes. Answer is A. So there is a strong association because the largest value is this one for each row and each column, right? And this one is also for this column is this one, and for this row this one is also the larger one. So in this case, the largest value is pretty much on the diagonal one. So it does not matter in which direction this diagonal is, but as long as it is on the diagonal term, then we will regard it as a strong association. So that's the answer for this is the A. Okay. Right now I'm going to give you an example of in what case or what characteristic of our 2 by 2 table will be like when there is no strong association. So this is a perfect example for the case where we don't have a strong association for these two factors. So in this case, so say if you look at from this direction, so when it is a sunny day, the cat will be very happy. Will will be happy in 10 days and will be sad only in 2 days. So the ratio here is 5:1, right? And for the raining day, the cat will be happy 5 days and only sad for 1 day. In that case, the ratio is still 5:1. So what is implies here is that no matter which weather you are in, the cat will be happy anyway, because the majority of the time it will be very happy. So in that case, there's no association or there's no impact of the weather to the moods of the cat. And if you look at from the second direction, so when cat is happy, the ratio between the sunny and rainy is 2.1 and 2:1. And for when cat is sad, the ratio is still 2:1. So in that case, it also means that these two factors are not associated at all. So in this specific example, the largest value here is in fact displayed in the same column. And in that case, there's no association for that one. Okay, so right now, I show you an example of how we use 2 by 2 table to draw the conclusion about the association. But for today's lecture, we're not really require you to understand how to draw this 2 by 2 table, because here I'm just trying to use the 2 by 2 table to give you an example or give you a sense of what is association is like. And we're going to come back to this point in the following lectures, probably in the lecture 7 or 8, to talk about specifically how do we draw conclusion using our data about whether there's an association or not. Okay, so this is the first type of the data. Oh, sorry, the first type of the study design, which is the survey data. So survey data is like you are taking a snapshot where at the point when you design when you design your study, you already observed both your response and your covariate. And now let's look at a different type of it. And the second type is called the cohort study. So in the cohort study, what we're trying to do is we first of all, we start with the complete sample that we already get. And then instead of, at that time, we did not really know like what's their data in the exposure and what's the specific data for the outcome. So what we know is about what's the different level of their exposure. So we are going to classify the individuals into either they have been exposed or not. So for example, if I collect the all of the students in this class, and I haven't give you the quiz yet, but I know that some of you will going to take it through the Zoom proctoring, and another part of you will going to take it through the Proctor track. So that's pretty much what is it about. And at this point, I haven't distributed the quiz yet, so I didn't know what is your score. So I will collect the score afterwards. So I will trying to observe what's the percentage of the students who has the Zoom proctoring and what's their average score about. And, and specifically, I'm also looking at for those students who are taking through the Proctor track, what is their scores about. So in my case, I'm talking about the continuous variable. But for discrete, we usually compare either how many or what's the percentage of the students with the outcome when they exposure, and what's the percentage of the student with the outcome when they are unexposed. So in the cohort study, the time frame is like we're looking at this prospectively, which means we start from the beginning where we only know that you could have different exposure or different explanatory variable value. However, we didn't know yet about your outcome. And in that case, the follow-up, the logic flow is it's from the beginning to the end. And if we come back to the example in our first lecture, where we discussed there's a study in Canada trying to study the association of the smoking status with the lung cancer development. So for that study, it is a typical example for the cohort study. So at the beginning of the study in 1987, they recruit two groups of the individuals who are they are all male, and we know that some of them are smokers and some of them are non-smokers. So which means at this type of from this point, we only know like what is their exposure or what is their explanatory variable, but we don't know what's their outcome. So that's why we follow up for another 2 years. And finally, in the year of 1989, we're going to collect what's their value of the outcome. And so for the first group, there are more than 15% develop lung cancer. And for the second group, there are no more than 2%. So in this way, you can see that the logic flow is prospectively in a sense that we are starting from the year of 1987 to the year of 1989. So any questions so far? So for the cohort study, you can see that it is quite different from the survey study in a sense that for the survey study, when we design our study, we already know all of what is our exposure and what is our, what's the value in our exposure and what's the value in our response. But for the cohort study, we only know what's the value in our exposure, but we don't know for what's the value of the outcome. So in this case, the cohort study do has a lot of advantage than the survey. So for example, for the cohort study, we know that it is the prospective design, which is we start from the earlier time and then we follow it up. And by that means, we are sure that we know our exposure can cause the outcome. So for example, in the smoking status study, we know that the smoking will cause the lung cancer. rather than the other way around, because our exposure to the smoking coming first, right? So that's the benefit of choosing the prospective design. That is, we do have the correct logic flow here, in a sense that we know the exposure precedes the outcome. And the second benefits of choosing the cohort study is that we can easily study the multiple outcomes. For example, in the smoking study, so rather than just observing the lung cancer, we can also observe other cancer when we're following up those subjects. For example, we can observe whether they develop the, say, the skin cancer or head and neck cancer or something like that. So we can study multiple different outcomes simultaneously. But of course, all of these benefits coming with several prices. For example, for the cohort study, it do it does require a really long follow-up time. So this is not always true, but at least for this study, it takes like 2 years for these individuals to follow up the different uh, exposure group. So this is because sometimes you just need time for those different groups to develop cancer, right? Because apparently cancer cannot be developed at the same day. So in that sense, we for the cohort study, we do have to follow up for a lot of time. But yeah, of course, in some cases, we can in some scenario we do have the case where we don't have that long following up time. But mostly, I will consider this as the disadvantage of the cohort study. And also, another problem for the cohort study is that it is not friendly to the study of the rare disease. So, for example, the lung cancer is probably fine in the sense that the percentage is still large. So, if we study a very, very rare disease like autism or some other type of disease, like even if you recruit 1,000 individuals, and finally, only probably one or two of them will end up with developing the disease. So in that case, the cohort study is not very suitable for that type of study, because unless you recruit a really, really large sample size in your original data, otherwise you probably end up with nothing. And also, the third disadvantage is that because we are following up those individuals for 2 years, so we have to make sure that we are actively tracking the results. Otherwise, we could lose our samples, right? For example, for these 2 years, so there's a lot of things could happen. For example, they could move out of the city, and some of them could die for the other reason. So it's really hard to really keep tracking those data, especially for the study where we have a long tracking interval. So that's another disadvantage for the cohort study. So far, any question for the cohort study? Okay, then we're going to head into the third type of the study, of the observational study, which is called the case control study. So the case control study is basically looking at the problem in another or in the opposite direction. So instead of start with the exposure, we directly start with our outcome. So for example, in our Cheetos example, uh, we already um, we already have some times that the Cheeto is sad and sometimes the Cheeto is happy. So we already observe their outcome. And we are going to look retrospectively on each day. So for example, I'm going to look up the weather forecasting, oh sorry, the weather in the past history, and to look at how many days it is sunny and how many days it is raining. So in this case, our logic flow is actually backwards, or in our words, is retrospectively. So we start from the end where we already know the results of the outcome, and then we are going to either doing a questionnaire or doing a phone call to those individuals to ask whether they exposure or not. So if we're trying to change the study design for our original example of the smoking status, what we'll do is we will start at the end, which is in 1989. And we're going to, instead of recruit the individuals according to their exposure, we're going to recruit the individuals according to their outcome. So we recruit 1,000 males with lung cancer and 1,000 males without lung cancer. And then we just ask them to recall, like, what's their smoking status? Are they smoking very frequently in the past 2 years, or they just smoke not that much, or they are not smoke at all? In that case, we can compare like what's the percentage of the smokers in different groups. So for example, here we observe that 85% of the individuals who develop lung cancer will smoke, and only 15% for the individual without lung cancer smoke. So in that case, we are actually doing backwards in a sense that we start at the end and then we finally trying to look back like long times before. So the benefit of trying to use the case control study is that it is really fast to run, or it is very easy to run, right? Because when we're trying to look back, we just send out the questionnaire to the patients or to the individuals in our study. So we don't really need to follow them up. And also it's really good for a rare outcome. So if we are studying a rare disease, we are just keep trying to recruit a really or enough sample size for the disease group. So we can sure that at the point when we're conducting a study, we already have enough individuals who have the disease. And also, we can study the association of our outcome with the multiple exposure. So for example, in this modified version of the smoking status study, we can, in a questionnaire, we can ask their smoking status. We can also asking about their education level, and also what's their, say, their marital status. So we can study a lot of exposures or explanatory variables simultaneously in the case control study. So you can see that some of the problems in the cohort study is being solved in the case control study. But of course, the benefits in the cohort study is exactly the problem for the case control study. So like we cannot tell what's the temporal relationship when we identify there is a relationship between the response and the explanatory variable. For example, in this smoking status analysis, we cannot tell like which comes first because we just ask them to record, right? We don't know like either is it because those individuals develop the cancer such that the cancer makes them want to smoke, or it's because the smoking caused the answer, right? So we cannot tell what's the temporal relationship, like who comes first. So that's the first problem for the case control study. And the second problem will be the recall bias. So remember, in this study, we are trying to ask the individuals to do a questionnaire, and we are trying to ask them to recall. And for a lot of times, people are just bad at memory things, right? And especially for those individual who has lung cancer, right? Because for individual who has the cancer, they probably have even worse performance in memorizing the things. So in that case, the results of their exposure could be unreliable because they probably falsely recalls their smoking status in our example. So these three different type of the studies pretty much the observational study we are going to talk about today. And to help you to understand or to compare these three different study, I trying to format them into this table according to several levels of the characteristics. So right now, let's do a quick iClicker check. Like you just tell me which, according to the level you, according to the value you're seeing, what type of the design it should belongs to or refers to. So right now we use A refers to survey and B refers to cohort and case control. So for the first one, say we have like, we are sampling our data according to our outcome. And we are comparing the exposure and we are looking at it retrospectively. What type of the study is it? So these three different features are actually the main features that we can tell the difference of these three different observational studies. So yeah, I guess majority of you get it right. So the first one is case control study, because in case control, we start with the outcome and then we ask the individuals to record their exposure. So the time frame here is retrospectively. So how about the second one? So we start with the exposure and then we're comparing what's their different outcome. Yeah, so as you can see, sorry, the second column is exactly opposite to the first column. So for the opposite design, it is exactly the cohort study. So in the cohort study, we start with the exposure and we're going to follow up those individuals for a really long times, and then we look at their outcome. So the time frame here is prospectively. And of course, the last type will be survey. So for the survey data, we don't really sampling our data because at the time point we do the survey study, we already observe those individuals. Like you can just use the data set from other study, and that at that point, all of the data in the either the explanatory variable or the response are known to us. So that's why we didn't consider any type of entry here. But here we are both comparing the exposure and outcome. Remember when we're doing the 2x2 table, we can look at the table from the both direction. We can look at the horizontally and also vertically. And the time frame here is basically that telling us that the survey is the snapshot, because at that time point, we already know all of the data. So right now, I think you should be able to tell what's the difference of these three different type of the observational study. And right now, I'm going to head to the, I would say the most difficult part for the most difficult concept for today, which is actually also the most frequent problem for the observational study, which is called the confounding effect. So the confounding effect is defined as the factor that is associated with both our explanatory variable and our response. And this factor, it will distort the relationship between our explanatory variable and outcome. So here I use the example. So for example, what we are trying to study is the Cheetos moods, right? And in our previous conclusion, we draw that according to the data we have, we see that our weather could influence the moods of the cat. But it could be wrong because, in fact, Cheeto is very happy every time my friend take it out. And Cheeto will be very sad every time when my friend just leave it at home. So apparently, the decision of my friends of whether walking the cat or not, this is strongly associated with the moods of the cat. And on the other hand, if you look at the relationship of the weather and the, the state of the cat walking, these two factors are also connected, because for the sunny day, my friend is more likely to walk the cat. And for the raining day, my friend is less likely to walk the cat, or even so, she will probably just walk the cat in the hallway. So in that case, the association of the weather and the moods of the cat are actually false. There is no such a association, but it is the factor that my friend whether walk the cat or not come into play. That it is this factor associated with response rather than our weather. So we call this confounding effect because these factors trying come into play such that we falsely observe such kind of association between the weather and the different moods. So that's why we defined the confounding effect as the association to be distorted when our primary exposure, which is the weather here, is mixed up with some other factor, which is the status of whether walking the cat or not. And also, this status is also associated with our outcome, such that we distort the relationship of our original study. Any questions so far? I know this, if you first heard of the confounding effect, this probably uh, quite overwhelming and it's hard to understand. So I just don't want to skip further with question in your mind. So if you have any question, just let me know. Okay, so now I'm trying to use some data to show you why there is a confounding effect in this case. So remember originally the data we collect is the different weather and the different moods of the cat, right? And right now, if my friend also have another line to record whether on that day she walked the cat or not. So in that case, we have three different variables, right? And we are going to group our 2 by 2 table according to whether she walked the cat or not. So at the days when my friend walked the cat, we see that the majority sunny day, the cat will be very happy. But if when there's a raining day, if my friend still walk the cat is still be very happy. So in fact, the largest point is in the same column. So which means these two factors are not really associated. However, for the second group, where my friend didn't walk the cat, and you can see that no matter what weather we are in, the cat will be sad anyway. So that's why, in fact, what will determine the moods of the cat is the status of that whether my friend walked the cat or not, rather than whether what's the weather about. So in fact, if you merge these 2 by 2 table by summing up each corresponding term, and you will end up with our original 2 by 2 table, where you will see a very strong association because of there's a large value in the diagonal term. And that's why, just because of this factor, we falsely believe that our weather is really associated with different moods of the cat, even if it is not. So that's why we call this a confounding effect. And for this type of the factor or the variable, we have a special name for it. We usually call it the confounder to denote that, okay, this variable can confound our original association. And this confounder in many studies, it could be known to us and it also could be unknown. So in some observational study, we just don't know what type of the things that could be confound our results, right? Like for the study of the different proctoring approach and your score, this study can also be confounded by other reasons. For example, the uh, one thing that coming up to my mind uh, is the working time of the quiz. Like for the Zoom study, for the Zoom approach, all of the students are taking in the morning. But for the Proctor track, some of them take in the morning, but some students take in the afternoon. And probably whether you take in the morning and afternoon will come into play in your results, right? So this could be a confounding, could be a confounder. So here I'm trying to explain one of the main problem for the observational study is that because for the observational study, we are just based on all of the data we have. We didn't really to play with, really manipulate with it. So sometimes we could end up with some unknown confounding effect in our observational study. Okay, so any question for the confounding effect? This is a very important concept. Any questions so far? So there's a question about if you found the confounder, do you reject the original association then, or it is just considered a possibility? So I would say the answer is it depends. So for it depends on whether we are sure that it is really a confounder. If we really know it's a really confounder, then we have to use some fancier statistical model to consider to take that confounder in to study the relationship. So we will not directly reject it. But for our case, we can reject it because if you look at this two by two table, there's no really relationship between them because from the results of this group and the results of this group, there's no really relationship between the weather and the cat's mood. So we can reject the results. And for some of the cases where even if we know the confounder and we cannot draw the two by two table like this, and then we have to use some other method to help us to decide whether the association is true or not. So that will require some further study. So what does, there's a question about what does the table on the bottom represent? Does that include walks and non-walks? So yeah, so this table is actually our original table, right? From our original table, we just ignore whether we walk the cat or not. So in that case, we just look at what's the association between the weather and the cat's mood, and there's nothing to do with the walking status of the cat. So this is also combined by these two data. So you can consider we further categorize each cell into two different groups. Either it's being walked or not. So the upper two tables are the case where we consider the walking status. And for the bottom one, we don't consider that. And that's why we see a problem here because we do see a strong association, but that's false because we didn't consider this walking status. Yes, so there's a question about if the circle is vertical and there's no association. Right, because right now, if you look at, say, if you look at from this direction, no matter what weather you are in, or for example, for the sunny day, the cat will, the majority days, the cat will be happy, right? And for the rainy day, majority the cat will be still be happy. So which means no matter which type of the weather you are in, the cat will be the cat will be happy anyway. So in that case, the vertical just implies there's no association. And if there's association, we should see a large number on the diagonal term, either this way or this way. Okay, if we don't have any other question, let's take a 10 minutes break. And then after you coming back, we're going to look at the second half of the study design, which is the experimental design. So the question, there's a question about, in this example, the confounder was the walking status. Yes, that's correct. Because if you can, so either you consider the walking status or not will influence the association. That's why we say this factor confound our results. And that's why we say this factor is the confounder in our case.
I don't think I'm genuinely that happy.
Okay, so welcome back and let's keep going. Um, so in the second half of the class, I'm going to talk about the second big type of the studies, which is the experimental studies, or sometimes we call it experimental design, where you are going to also look at several different subtypes for the experimental designs. And remember, for the experimental studies, the difference for the for the observational study is that um, our explanatory variable here will be manipulated. In fact, the reason that we're trying to manipulate our explanatory variable is just trying to fix the confounding problem that is commonly appeared in observational study. So right now, I'm going to change my example a little bit. So say right now, I'm not going to study what's the relationship between the weather and cat mood. I'm trying to study the different brands of the cat food and the cat moods. And the second difference is that instead of just study Cheeto, I'm also uh, I'm trying to generalize my data. I'm going to study the whole cat population. So I want to see, like in general, what's the cat's reaction for the moods for different brands. So right now, our explanatory variable or our exposure will be the different brands. And the outcome or the response will be still the different level of the mood. And in this case, our both of our explanatory variable and outcome, they are still discrete. And for the specific context of the experimental design, we have a special name for the explanatory variable, which is the treatment. So we usually use the terminology treatment in the clinical trials, but we usually also generalize this term in many other studies. So you can just regard this treatment as the explanatory variable in the experimental design setting. So which in our case, our treatment will be the different level of the cat's food. And one of the reasons that we use the word treatment rather than exposure or some other words is that for treatment, it's precisely describe the fact that we're going to manipulate uh, whether the cat or manipulate which brand the cat will get the food. So for the first type of the randomized design is like you can compare this to our original cohort study in observational study. So we start with the complete cat population and we draw a sample from the cat population. And among these sample, instead of just to grouping them according to several characteristics that we observed, we are trying to randomly assign each cat into different groups. So some cats will be in the treatment group and another set of the cats will be in the control group. So we can say for the treatment group, the cats will take the brand A, and in the control group, those cats will take brand B. And similar to the cohort study, and we're still going to follow up those cats for a really long time and to see what's their reaction, whether they have a happy mood or a sad mood. So far, it is exactly this. I would not say exactly the same, but it's very similar to our cohort study. But the only difference is that we do have a randomization in the beginning or when we're trying to define the different groups. So like in our cats example, we start from the cat population and we can roll a dice or we can draw a note from the hat to randomly assign those cats into two different groups. And when we observe the different level of their outcomes. So why this randomization can help us to get rid of the confounding effect that is very commonly appeared in observational study. So again, we are still looking at this similar diagram, but this case, right now, we don't have a weather here, but instead we have, say, we have a different brand of the cat food. Because right now, we already discussed that we're concerned that whether we walk the cat or not could be a confounder that play into the association, because we know that this could be really influence our results. And possibly, it's possible that these two variable, like the brands and the walking status, could be associated in a sense that for the owners, the cat owners who walking the cat more frequently, she will probably choose the first brand, while for the owners who doesn't, will choose the second brand. And in that case, we will still have possible relationship between these two variables. So when we do randomization, because we randomly assign each cat into brand, so in that case, we break the association between these two variables, because whether the cat, so which food the cat receive will entirely based on our dice, or entirely based on the notes they drawing from the hat. And instead, it cannot associate with their status of the walking cat. So in that case, we will be sure that if we observe association between the cat food and the cat mood, and then we are sure that this association will be true and they are real association. And also, I want to emphasize that even if we do the randomization, that does not mean that we completely get rid of the confounding effect, because doing randomization just means we're trying to get rid of the confounding effect before we did the randomization. But after we did the randomization, we still can introduce some other factors that could be the confounding effect. For example, in this cat study, say if we record, finally I assign each cat with different food, and then I'm trying to record their moods. Say for the happy cat, or say for the cat who take the first brand, and record the moods in the outdoor. And for the cat who taking the second type of the brand, I'm taking the records indoor. So basically, right now, the outdoor indoor will be our new confounding effect. And this part is not being randomized because that's coming after we do the randomization. So yeah, just be very careful about this point. And so far, what we look at is the complete randomization, which means we just completely randomize each individuals into each group. But because the randomization is the things that we cannot control, sometimes it will be end up with a very bad scenario. For example, we know that whether we're walking the cat or not could be our confounder, right? So sometimes we're just so unlucky that we accidentally, based on our dice, we just assign all of the cats whose owner walking them frequently to be the first brand, while the remaining cats whose owner doesn't walk them very frequently to the second brand. In that case, we actually failed to adjust for the confounder, although we didn't know it. So in this case, in some scenarios, say we exactly know what could be our confounding factor or confounders. In that case, we can introduce a fancier method to do the randomization. So that's why we introduced this randomized block design. So for randomized block design, we're going to step one step further, in a sense that before we do the randomization, we are going to group those cats according to they have been walked or not. So after grouping these cats into two blocks. And then we're going to randomly assign those cats within each block. So the reasoning of doing this that we can make sure that no matter whether you walk the cat or not, you are still possibility to get the two different cats. So in that way, we can purposely control the possible confounding effect coming from the status of the cat walking. And in this case, our randomization will be coming to play in our second stage, which is between after we block those cats and before we finally identify their outcome. And here, I would like to emphasize that choosing your block factor is very tricky in a sense that you cannot choose your the primary interest to be your blocking factor. If you block your study by the different cats, then you cannot study what's the relationship between your cat food and your cat's mood, because your explanatory variable has been blocked. So in that case, you have to be very cautious about the blocking variable that you are choosing. And for the most scenarios, we're just choosing the blocking factor according to which factor we believe it could be the confounding effect. And sometimes blocking factors, it's still, we have to do randomization within each block. And there's even more one step further. And in that case, we introduce the matched pairs design. So you can consider the matched pairs design to be a sub-design or subtype of the design for the block design. So in the matched pair design, it is kind of going to in the extreme in a sense that we are trying to find two cats that is almost the same. Like, for example, they could be the twins, except that we are going to give them different treatment. So you can consider each different pairs as a block. And of course, right now, you almost control all the other confounding effect because these cats are so similar with each other. But still, we have to introduce our randomization. So we are going to randomly assign each cat to different treatment. So in the match pair design, we still have some randomization come into play. So it doesn't mean if we match those cats into pairs, then we don't need to do any randomization. Okay, any questions so far for all of this randomization design? So what's the difference between the treatment and control? Okay, yeah, maybe this is not such a good example, but in clinical trial, we usually take the treatment as like the medicine group, the group where the individual will take the medicine, and the control group will just do nothing. So that's why by control we mean that we are trying to control the results of the or compare the results with the treatment group. So here, this is a bad example in a sense that you can consider both of them is pretty much like a treatment because you can treat the first brand as your treatment and second one as the control group. So you are comparing these two, or you can choose the second one to be the treatment and the first one as control. So the idea for treatment and control here is not so clear, but for this division, it's more clear in the clinical trial setting. So there's another question about do the matched pairs have randomization at each branch division? Yes, that's true. So for the matched pairs design, remember the matched pair design is a very, I would say it's a subtype of the block design. And for the block design, we do the randomization within each block. And for the match pair, you basically can treat each pair as a block. So for each pair, you are going to randomly assign to do randomization. So for first pair, you're going to randomize which cats get which. And for the second one, you also do it again. So you're going to repeatedly randomize their treatment within each pair. And for this case, we can make sure that for each pair, at least one cat will get brand A and another cat will get brand B. But which get which, it will be randomized. So there's a question that from all cats to the pairs. Also from this step to this step, is that randomization? No, that's not randomization. So we for the matching step, we're just trying to find. So for example, we already get this cat, and in the matching step, we're trying to find another cat which is the most similar to this cat in a sense that they have the same age, they are in the same breed, and they have similar owner or something like that. So we're trying to find another cat which is by matching, it means we're trying to find another individual which is most similar to this individual, as similar as possible. So there is no like randomization in this plot. And there's a question about, can I explain the block design again? Right, so for block design, the reason we're trying to block the variable is because we believe some variable could be the confounding effect. And we are not sure whether the completely randomization design could get rid of that. So in that case, when we know that we're sure that one variable could be the confounding, then we will take something to do with it, right? And in that case, we will introduce this block design. So for the block design, we first of all, we group all of the sample in our data according to whether I would say according to which group this sample belongs to in our confounding factor. So for now, we believe that the confounding factor is whether the owner walked the cat or not. So we just group each cat according to whether his or her owner will walk him or her a lot. For example, if this cat, if his owner walk him very frequently, then we will just assign it to the first category. And the second cat, okay, uh, her owner just make her stay at home, then we will assign it to the second block. So in this blocking step, you can see that there's no randomization come into play. Because we assign those individuals according to the characteristic of the walking status. So there's no randomization come into play. And the randomization is only coming to play on the second stage, where for each block, we're going to randomly give each cat different type of the treatment. Okay, there's some confusion about why we cannot use the primary factors of the interest for blocking. So remember, for the blocking, so I guess this sentence, what I mean is that for when you choose the blocking status, you cannot choose the variable that you are studying. For example, right now, the variable that we're trying to study is the brand, the brand of the food. If you block your sample size according to the brand, then you cannot study what's their relationship, because you cannot do randomization based on that, right? Because this cat, for example, this group, if you group it according to the brand, then you already decide what's the treatment for this group, and there's no point of doing randomization. So that's why we never choose the primary factor of the interest for the blocking. So now another question is block design the same as the match pair design, just with a bigger group of individuals? Yeah, I think your understanding is correct. So because the matched pair design is a very special case for the block design, and in a sense that the matched pair design we usually only consider two different individuals in each block. So yes, I think your statement is correct. Because the block design, we do have a lot more individuals in each group. So when would you opt for the match pairs design over the random block design? So if you compare these two different type of the design, so the block design is you are trying to blocking a specific characteristics that you believe could be the confounder, right? But for the match pairs, we step further. We're trying to block everything. So you can see that the match pair it's actually a better design uh, than the blocking design, in a sense that the match design you control even a uh, broad scope of the variables that could be our confounder. So usually the match pairs design is preferred than the block design. But the problem is that, as you can imagine, for when you design a match pair design, you have to find like very similar individual uh, for each another individual. And for this match pairs, you usually taken place in like the study of the twins. So in that case, it's really hard uh, to to have such kind of uh, enough data to do the match pair design, because sometimes you just cannot find another person which is so similar like you. So in that case, the match pairs design, although it control a lot of the possible confounding factors, but the problem is it's not so realistic in some cases because it has a really large requirement on your data set. So, but of course, if we can do the matched pairs, it will be preferred because comparing to these two different designs, the match pair design just control more confounding effect. Any other question about the randomized design? Okay, so this is actually pretty much for today. And um, for this week, we do have an independent material, which is talking about the principle of designing our experimental studies. And because as you can see, for today's lecture, you have see a lot of new concepts. So I guess the best way to do this independent material is that you first finish the first half of the practice questions, which I will probably post this evening. And I will label like which part, which question belongs to, and you will see that uh, which part of the question that requires you to watch the video. And so after you finish the first half of the practice question, then you have a better sense of what's the difference between the observational study and the experimental study, and what's the difference or similarity within each group. And then you can go ahead to watch the video, and where we are going to look at this problem in a higher point of view, in a sense that we're talking about the principles of the study design. And right now, our assignment 2 is available on OWL, and you can check it out. And the due date will be the next Monday. And the time will be 1 p.m. In the Toronto time. So I didn't choose the noon because I guess some student will be kind of confused by the 12 a.m. and 12 p.m. So I guess 1 p.m. is a safer way to choose the deadline. And also, just so you know that you can ask for regrade for your assignment one if you are not sure why you lose mark. And in that case, you can just go to the grade scope, and I'm pretty sure there's a button that saying you can click it and to ask for a regrade, and then you just do that, and TA or I will regrade the assignment for you. But just so you know that when you need to write the reason that you're asking us for the regrading, and also there's no guarantee that the regrade mark will be higher than your original mark. Is there a quiz this week? Yes. So there will be a following up post video quiz to asking you question about the materials in the video. I have not gotten my midterm mark back. They out for everyone. I think the midterm mark should be out already. So you can check it on the text and exam tab, and you can also check it on the grade book. There's no quiz from the last week. So the last week you are done everything. Yeah. Yeah, so there's a question about can we see which we got wrong? Yeah, I think the feedback for the the feedback for the first meeting is also out. So when you go to the exam and the test tab, you should see the feedback for each question. And also I post the solution or the answer keys for the midterm one in the administration tab. So you can also check it there. So there's question about when will assignment mark show up in OWL on the gradebook? Because there's still some student asking for the regrading, so probably it will show up this Friday, I would say. Yeah. Okay, so this is the end of the course, and I'm just staying here for question. And if you don't have any question, you are free to go. Okay. Oh, it might be like, so some student didn't see the mark. It might be the case where for the student with the accommodation, I think I might set a different time for the release the release date of the marks, but I will check it later. Okay, there's a student asking, explain the First Nations question again. Okay, so actually, the First Nations question is very challenging in a sense that it actually asks you several things. So first of all, it asks you what's the median of this table, right? And second, uh, although I didn't write it out, but it actually asks you what type of the data you are working on. So because for the First Nation question, um, I I put a note to give you a hint that the different group of this for each category, they should be treated equally or equivalently in a sense that there is no way to sort them out. So in that sense, you cannot consider it to be ordinal data or even continuous data. So it can just be the nominal data. And for the nominal data, we cannot tell the median. right? Like for the color, for the blue, yellow, red, can you tell the median among them? You cannot. So because the reason is that you cannot sort those data out. So since there's no order, so there's no point to talk about median. So that's why the answer should be the nominal data does not talk about the median. If I request a regrade on my assignment, could I potentially get a mark lower than the original one? Yeah, that's possible because, for example, sometimes TA might find some part he missed out, then he will probably change that part too. Because when we regrading, we regrade the complete assignment or not just the part that you're asking us to look at. So that's still possible. So the following up question for the First Nation question. So if a question ever states that we need to treat each group equally, it would be considered nominal data. It is still nominal data because I put that note is just for your hint, just trying to help you to notice that it is a nominal data. But the data itself, it is what it is. So because for those data, you cannot order it, right? So itself it's still a nominal data. Okay, there's a follow-up question. Maybe I'll just